Okay, good morning. So I tried to record this video once last night and apparently it did not register. So I'm going to make a quick video here and just try to do this, like I said, as quick as I can. So feel free to pause the video anytime that you need to. But today we're going to talk about using systems. So the things we've been working on the last couple of days to help us solve super long equations. So I'm talking about things like this, right? If we look at this, we've got multiple fractions in here. We got some other values. So I want you to take a moment, see if you can do it on your own. If so, then you're, kind of ahead of the curve right now. But you want to combine the like terms on the right-hand side and then solve for x. So pause the video, see if you can do it on your own. I'll be back in just a moment. Okay. Hopefully you took a moment to pause and work on that your own. But if not, I understand this is a pretty complicated problem. So I'm going to go ahead and show you what I did earlier that, of course, did not show up. There we go. And so let me explain through the answer here. But the answer was, in fact, 11. The first thing that we needed to do was combine the fractions on the right-hand side. Since they both have a denominator of 3, that means you can just combine the tops. And that gives you 7. And then, so now we're left with 7x minus 7 thirds x minus 9 equals 4 thirds x plus 2. From there, you can add 9 to both sides. So that gives you 11, right? 2 plus 9 gives you 11. And then you can subtract 4 thirds from the left to the right. And that's going to give you 7 minus 4 gives you 3. So 3 thirds x equals 11. Okay? And we say that because 3 over 3 equals 1. And if it's 1x equals 11, well, that's just like dividing by 1, and you're going to still end up with the same thing. Okay? All right, so what was the point of that? Well, that was super tough, but there's another way to solve these types of problems. You can actually use Desmos and graphing to be our friend, because instead of working through these fractions algebraically, we can use them as slopes, which we're more accustomed to, rise over run. And so what we'll do is we'll take these equations and we'll actually split them up. And what we're going to look for is the intersection, right? So in all three of these examples that you see below, I went ahead and split up the equations. Yes, I understand this one's really easy to solve. It's just demonstrating another way in our tool chest that we could use to solve these equations. So 3x minus 4 equals 5. Split that up to y equals 3x minus 4, y equals 5. And then we go ahead and graph it. Okay, and once again, I did this earlier, so I'm going to go ahead and highlight it here and show you what that looks like. Looks like that. Okay, so you got y equals 5 is this line up top, right? Goes to y 5, and then the other ones, it starts at negative 4, goes up 3 over 1, up 3 over 1, up 3 over 1. And so these connect at 3, 5. I apologize. My voice is awful today with the game last night. Okay. The next one, 3x minus 4 is on the left-hand side. Or, I'm sorry, 3/5 x minus 4 is on the left side, so we put that there. And then negative 2/5 x plus 1 is on the right, so we put that there. And again, you could solve this algebraically, but now you're working with fractions that we would not want to necessarily work with, right? So instead, what we'll do is go ahead and graph them. Start this one at negative 4, or the top one at negative 4, and then go up 3 over 5. So at the bottom one at positive 1, and then goes down 2 over 5. And it looks something like this. Okay. So the top one, 3/5 x minus 4, starts at negative 4, goes up 3 over 5, up 3 over 5. The bottom one starts at a positive 1, and then goes down 2 over 5. And then up to left 5, since we ran out of space. Okay, so that solution is 5, negative 1. Okay. All right, last one here on that problem, or this type of problem, you're going to split it up once more. You got negative 2x plus 4, negative 2x minus 1. Split those up. And what you notice is that they both have the same slope. And since they have the same slope, that means that they're going to be parallel lines. It looks just like that. Okay, one starts at a positive 4, goes down 2 over 1, down 2 over 1. The other one starts at negative 1, goes down 2 over 1. Okay? And so these are parallel lines, which means that there are no solutions. Okay. Again, I apologize. I have a cough drop in here, just trying to get my voice to work for me here a little bit. But that's kind of the idea of today's notes, right? Just using a system of equations to be able to solve when we have super long and complicated equal sign equations, right? Same idea here. You can see that this is pretty long. We could solve it algebraically by distributing and running through all of that. But instead, let's just take those two equations, split it at the equal sign, and split them up so that we can graph them in Desmos. Looks something like that. Okay, so again, pause anytime you need to. I'm trying to go quick here because I thought the video uploaded, and then of course it did not, so I'm trying to give you a video to watch. Okay, the solution in this case to this equation, if you use Desmos and type it in, is, and I did this earlier, right there. So the solution is, when you type both of those equations into Desmos, click the button, 1.18 and 1.294. So pretty? No. But it's there. Okay, so lastly it says using systems to fill the following tables. We're going to do the same thing, right? We're going to fill out the table, y equals 2x plus 6. Okay, convert it to a table. Right, you hit the settings button and convert it to a table. All right, that looks like that. So now we can fill out some of the answers that it has, like 1, 8 is in there, and -1, 4 is in the table. But we don't have the other one. So what can we use? Well, we know that this is a y value, so we could say y equals 14 and see where that connects, which in this case is at 4.14. If I can get it to connect, there we go. So that would be 4. And then since this one's an x value, you could say x equals 7, or you could just type the 7 into the table, and that's going to give you 20. All right, so that's kind of easier way to fill out that table, use that top equation. Okay, so now doing the same thing with the bottom one. It says you try. If you want to pause it and try it on your own, you can. But again, I'm just filling this out for the sake of time. So you have negative 3x minus 2. That's that graph. Okay, click out of it. Now you can see that we have -1 is a +1 result. +1 is a -5 result. We do not have a 14 here. So let's plug in y equals -14. See what we get. Oh, it is a 4 again. Okay, and then for 7, we don't know what that is either, so we're going to have to type that in. Or if we look at the pattern, it's going down 3 over 1. That's the slope, right? And so our first y value in the table was a 4. So if we just add an x value up above, which would be -3, it's going to actually present that 7 that we're looking for. Okay, so long story short, use Desmos, right? But when you have super complicated equations, you can split those equations, right, into 2 separate equations, graph them both, and then look to see on the graph where they intersect, okay? And that intersection is the solution. So you have an exit ticket to do. You're going to go ahead and complete this. All of the questions are very similar to the examples that I just went through for you. You're going to go ahead and turn this in. This will be your homework for today. And then go ahead and work on your levels or anything else that you need to. All right, guys, if you have any questions, please let me know. Send me a quick Canvas message. But if not, I will see you tomorrow.